Okay, so you'll notice that the way they have this divided up is into 3 different types of angles according to what types of segments or lines are making up the angles. And that's sometimes how you'll see this presented. And they call them tangent-tangent angles, tangent-secant angles, and secant-secant angles. So this would be a tangent-secant, this would be a tangent-tangent, this would be a secant-secant. We don't need to learn it that way. You don't have to worry about that. You don't have to get into what's a secant-secant or is it a tangent-secant or whatever. As long as we realize they all work the same way because they all have their vertex in the same place. All of these angles have a vertex that is outside the circle. So we can just throw them all in the same group and say, because their vertex is outside the circle, we're going to treat them all the same way. And we'll just think of these as angles with a vertex outside the circle. And the rule is the angle formed is half the difference between the 2 arcs. So just like inside the circle, we have 2 arcs intercepted, not 1. This time, instead of being half the sum of the 2 arcs, which was what we did with inside the circle, it's half the difference. So subtract. Difference means subtract. Okay, so looking at this first set over here, the tangent secant, angle 1 intercepts this arc and also this arc. Okay, those are the 2 arcs intercepted by angle 1. Okay, so I'm going to say that's arc BC and AC. And the measure of angle 1 is going to be half the difference between the 2 of those. So the difference between the measure of BC and AC is the measure of BC minus AC. Now, usually when we mean difference, we're talking about the positive difference. And that's the case here because I don't want a negative angle. So I'm not going to have half of a negative number. So we want to subtract in a way that makes it positive, which means the bigger one minus the smaller arc, which always means the one that's farther away minus the one that's closer to the angle's vertex. So it's the farther away arc minus the closer arc. If you do it in the opposite order, what happens? Yeah, you get negative, but it's the same number. So you could just go, oh, wait, that's not supposed to be negative. I did it in the wrong order and drop the negative sign. So it'd still be the same number. You'd still get it right. You'd just be like, oh, yeah, I subtracted in the wrong order. So don't give me negative angles. Okay. But if you do it wrong, you'll catch yourself with that. Next up, 2 tangents. We have the larger arc here from P to R through Q. And the smaller arc also goes from P to R, but not through Q. So notice that together, those 2 make up the whole circle. So my 2 intercepted arcs are PQR and PR. And so my angle 2 is half the difference. So that's the measure of PQR minus the measure of PR. And then it's a little bit easier to see the intercepted arcs on the 2 secants here. Here's the bigger one. Here's the smaller one. So angle 3 intercepts arcs XY and WZ. And its measure is half the difference between the measure of XY and WZ. So we're going to skip, once you finish writing that down, we're going to skip number 5 and go straight to number 6 and 7 first, and then come back to number 5. So the way I would write this, by the way, as a sort of word equation is I like to write this as angle is half one arc minus the other, bigger arc minus the smaller arc. The angle is 1/2 arc minus arc. And I've got quite a lag going on. Sorry about that. Not sure why. This happened last week, but then it stopped happening. Okay, so looking at number 6. We don't know the angle, and we do know the 2 arcs that are intercepted. So my 2 arcs that are intercepted are JF is the bigger one, HF is the smaller one. We're going to set it up, angle equals 1/2 arc minus arc. That's how we're going to set up our equation. So x equals 1/2 170 minus 72. So x is 1/2 of 98, and 49 is my answer for x. The next one is very similar. You've got two intercepted arcs. The difference on the next one is in what's missing. We're not missing the angle, we're missing one of the arcs. So we're still going to set it up the same way. Angle equals 1/2 arc minus arc. So my angle is 26 degrees equals 1/2 y minus 30. What's easier than multiplying, distributing that 1/2? Multiply both sides by 2. That gets rid of the 1/2 and gives me 52 equals y minus 30, which means y is 82. Okay, before we do number 5, because number 5, there's a little bit of a challenge to it. I want to do one that's very much like it. So I'm going to draw one that looks almost exactly the same. Okay, looking at this picture, what would I have to do to find x? Exactly. Okay, you have two arcs here, the 100 and then the x, and together they make up the whole circle. So if you have one of them and you're missing the other one, you're just going to subtract from 360 to get that one. So I would say, okay, this is 360 minus 100, which is 260. Okay, so over here on number 5, we kind of have to do that to get an expression for this arc, because we have an expression for this arc, that's x. We have the angle. I'm going to call x the blue arc. What I don't have is I don't have any way to refer to the orange arc. I don't have a number and I don't have a way to refer to it. But I do know that the rest of the circle is in the blue arc and it's x, so I can call the orange arc what? Not a different variable. Don't give me a different variable. How did you find it before? How did you find it on the other problem? If this was 100, I would do 360 minus it. Exactly. So it's just 360 minus x. When you're working with variables, the key is to ask yourself, what would I do if this was a number? What would I do if this was a number? I'd subtract it from 360. You still do exactly the same thing. The only difference is whether or not you can simplify it. If I subtract 100 from 360, I can, and I get 260. If I subtract x from 360, I just can't simplify it. I'll leave it like that. So now I'm going to do angle equals 1/2 arc minus arc, because now I have a way to refer to that arc. Excuse me. So the angle is 45 equals 1/2. The big arc is 360 minus x. So that whole part right there, that's just the big arc. And then I'm going to do minus the small arc, which is x. So it looks a little weird because you have the minus x, but this one's part of the big arc, and then there's the small arc. And then I can simplify that. 45 equals 1/2 of 360 minus 2x. And this time what's inside the parentheses, those are both even, so I could just distribute the 1/2. It would be pretty easy to do that. Or I could multiply both sides by 2, either way. I think I'm going to distribute this time. And I get 45 equals 1/2 of 360 minus 1/2 of 2x, which is just 1x. Subtract 180 from both sides, and negative 135 equals negative x, so x is positive 135. Questions on that one? I'm going to leave the 2 challenge problems at the bottom for you to do. And then you also have a delta math assignment.